in this video we're going to be looking at some exponential and logarithmic functions, the relationships between them and the inverses and the graphs of the inverse and the original function. So we're going to work down this list of questions. We're going to sketch the graph, describe the transformation on the standard graph, sketch the graph of the inverse function, and then try and identify the inverse function and justify our findings. So let's put the questions to the corner and make a start on the first equation. So the first equation we're going to look at is y equals e to the minus x. So first we want to sketch the graph of that. Obviously it's going to be a reflection of the graph of y equals e to the x. Y equals e to the x has an intercept on the y of 1 and an asymptote along the x-axis. So what kind of transformation is it? Well, it's f of minus x in brackets, and it's an inside transformation, so it's going to be a reflection in the y-axis. So we're going to get a graph like that. Still crosses at 1, and this time the asymptote still on the x-axis but on the other side of the x-axis. So it was actually a reflection of y equals e to the x in the y-axis. Okay, so first part done, second part done. Tick those off. Okay, so the next thing we're going to do is find the graph of the inverse function. So let's just over here just put the graph that we've just found, this one here, which is y equals e to the minus x, asymptote on the x-axis, intercept on the y-axis of 1. So to find the inverse, we need to reflect that graph in the line y equals x. Okay, and everything swaps over. So where we've got a intercept of 1 on the y-axis, on the new graph, we're going to have an intercept of 1 on the x-axis. Where we had an asymptote along the x-axis, positive part of that, we're going to have an asymptote on the positive part of the y-axis. So the graph we want is going to be that one. Okay, which is a reflection of the red one. Maybe I'll put a little bit more on that red one to show that it extends along there. In y equals x. So we just make that a little bit smaller. Now we want to find out what function that's the graph of. So if I just draw the blue graph on its own, okay, intercept there, asymptote there. So clearly it is a transformation of the graph of y equals ln x, as we would expect, and it's a reflection in this time in the x-axis. So the equation of this one is going to be y equals minus ln of x. Okay, so we're hoping that the inverse function of y equals e to the minus x is y equals minus ln of x. So we're just going to use an algebraic method to check that that's right. Looks right. But we'll just double check. Okay, so let's section off this bit to just prove the inverse algebraically. So we started off with y equals e to the minus x. In order to find the inverse algebraically, we need to make x the subject of that equation, and then we just swap over the x and the y at the end. So if we take lns of both sides, we've got ln of y is ln of e to the minus x. E and ln are inverses of each other, so we just end up with minus x there. So x is minus ln y, so the inverse function that we were looking for is minus ln x, which agrees with what we had before. Okay, right, try another one. So this time we're going to start with y equals ln x plus 2. Okay, so first thing to do is to draw a sketch of that. So we'll start with the graph of ln x, which is like that, crossing at 1, asymptote y. I've done something which is a bit dodgy here. It's hard with this pen though. My asymptote should really look, well, the graph should look like it's approaching the asymptote a little bit more than that does, so a bit more like that. Okay, so the transformation this time it's an outside transformation, so it's going to move the graph 2 up. So it will look very similar, but just everything will go up by 2. So it looks like that. So obviously this intercept is different to what it was before, and we need to find that. So the intercept is when y is equal to 0, so 0 will be equal to ln x plus 2. So minus 2 is ln x, and x is going to be e to the minus 2. So that intercept on the x-axis is at e to the minus 2. Okay, so we now want to find out what the inverse function is. So again, we're going to just sketch that one on its own. There's our graph, e to the minus 2, asymptote along here, and we want the inverse of that, so it's going to be a reflection again in y equals x. So the intercept on the y-axis is going to be e to the minus 2, and the asymptote was on the negative part of the x-axis. It's now going to be on the negative part of the y-axis, so over there, not quite there, but off the edge of my graph. So the graph will look like this. Something like that, not quite as wobbly as that, but you get the idea. Okay, so it smooths over a bit like that. Okay, so that's what the graph looks like. We now need to try and work out what it is. So just put it on its own, draw it a bit better this time. So we've got that graph, intercept is e to the minus 2. So we can see asymptote still along the x-axis. So we can see that that's clearly a transformation of y equals e to the x. So if I just put graph of y equals e to the x over here. Okay, so this point here, where x is minus 2, has moved along and is now the intercept. So we've got now the point here, which would have been e to the minus 2, is now on the axis. So clearly it's a shift in that direction of 2. Okay, so the equation we know from graph transformations of this equation, of this graph over here, is y equals e to the x minus 2. Okay, because it's gone plus 2 in that direction. Okay, so we've done most things, done that. The only thing we haven't done is our justification algebraically of our graph. So I need a bit of space for that, so let's just move everything up to the corner. And we'll justify that here. So we had started off with y equals ln x plus 2. Okay, so we're trying to make x the subject, so y minus 2 is ln x. Then we take both sides of the equation to e, so e to the y minus 2 is e to the ln x, which is just x. So the inverse function, what am I doing? Rub that out. Sorry, so the inverse function is e to the x minus 2, which agrees what we found from the graph over here. Okay.